Today's objective is I can solve real-world problems involving scale drawings. So here's the example we're going to look at. Over the break, your uncle and aunt ask you to help them cement the foundation of their newly purchased land, and they give you a top view blueprint of the area and proposed layout. A small legend in the corner states that 4 inches of length corresponds to an actual length of 52 feet. What is the scale factor? I'm going to go through and find the scale factor with you, but I'm also going to then point out we don't actually need to use that scale factor for any of the other parts to this question. We can answer the remaining parts of this question without ever knowing scale factor, but in this problem presented by New York State through Engage New York, they start off by asking you the scale factor, so I'm just trying to make sure I stay consistent with New York, but the rest of the problem won't even use this fact that we come up with in Part A. Okay, so what we're going to do is take 4 inches and 52 feet is 52 feet, and we're going to find the scale factor. Scale factor units must agree. That means we can go ahead and either convert 4 inches into feet or convert 52 feet into inches, but you have to have units that agree. I'm going to convert 52 feet into inches. So I'm going to take 52 times 12. 2 times 2 is 4, 2 times 5 is 10, 0 as a placeholder, 1 times 2 is 2, 1 times 5 is 5. Add those up. 4, 2, 5, and 1 is 6. So that tells us, and you can use your calculator. I don't have one in front of me at the moment, so I just went ahead and did long multiplication. So what that tells us is now we know 4 inches in our drawing represents 624 inches in the actual layout of the land. And the whole point to a scale factor is now that we have inches over inches, those agree, those inches are gone, and we're just left with this number, 4 over 624. Then I'm just going to write it in simplest form. So 4 over 624 is the scale factor. I'm going to choose to write it in simplest form by dividing top and bottom by 4. 4 divided by 4 is 1. 624 divided by 4. Let's see. 4 goes into 624. 4 goes into 6 once. Bring down that 2. 4 goes into 22 5 times. Bring down that 4. I'm just reminding you about long division. 4 goes into 24 6 times. Your scale factor is 1 over 156. That means 1 inch in the drawing represents 156 inches in real life. So there you have it. But again, I'm not going to use 1 over 156 in any other part of this problem. But this is how New York State presents it, so we're going to stick with what New York State does. Same exact question, except now it says if the dimensions of the foundation on the blueprint are 11 inches by 13 inches, what are the dimensions in actual feet? And again, when they're back to asking about actual feet, I know we don't want scale factor. We want to use just the scale they gave us. So we know 4 inches in the drawing is 52 feet. We do drawing over actual. And then I say to myself, okay, if my blueprint is 11 inches, what is the actual feet? So 4 times what is 11? 4 times what will give me 11, and that'll tell me what I have to multiply my 52 by. So I have to do 4 into 11. Because if I do 11 divided by 4, I'll know 4 times what gives me 11. So 4 goes into 11 twice. That's 8. We have 3. Bring down a 0. 4 goes into 37 times. Is that correct? 4 times 7 is 28. Bring down another 0 there. 4 goes into 2.75. So I have to multiply 4 by 2.75, which means I'll multiply 52 by that same value, 2.75. And I'm going to take 2.75 times 52. 5 times 2 is 10. 2 times 7 is 14, and 1 is 15. 2 times 2 is 4, and 1 is 5. You'll notice when we're multiplying decimals, we don't have to line up our decimal points. You just multiply as you normally would, and then we count up how many decimal points we need at the end, places we need at the end. That's in the tens place, so I'll put down a 0 as a placeholder. 5 times 5 is 25. Put down a 5, carry a 2. 5 times 7 is 12, and 2 is 14, right? No. 5 times 7 is 35. And 2 more, right? 35, 36, 37. 5 times 2 is 10, and that gets me to 13. Oh, let's hope I didn't make a mistake. 12, that's 13. That is a 4. Let's hope. 2 decimal places over because there was 2 decimal places over here. So I get 143 feet. So 11 inches would be 143 feet. You can be using a calculator to support you on this. In particular, it's an extended response. New York State allows calculators on an extended response. Had this been in book 1 of the state test, that's the only time you're not allowed it. Okay, so again, now I'm going to do inches over feet. I think this time I will use a calculator just for time savings. But this time I have to convert 4 to 13, so then 52 times what? Okay, so to figure out 4 times what is 13, I'm just on my calculator going to punch in 13 divided by 4. That gets me 3.25, so I know I need to multiply the 4 by 3.25, which means I multiply the 52 by 3.25. Whatever you do to the numerator, you do the same to the denominator. 52 times 3.25 is 169. So that's 169 feet. So when they ask about the dimensions, the actual dimensions would be 143 feet by 169 feet. So the actual dimensions would be 143 feet by 169 feet. Let's go to the next section. We need to remember those numbers though. 143 feet, 169 feet. So I just want to make sure. 143 feet by 169 feet. So same problem, but now we're going to, you're asked to go buy bags of dry cement, and you know that one bag covers 350 square feet. One bag covers 350 square feet. How many bags do you need to finish the project? So how many bags do you need to buy? So first of all, I have to know how many square feet I'm dealing with. So what I have to actually do is find this area. We know area of the rectangular section would be length times width, or base times height. So it's 143 times 169. Before I can figure out how many bags to buy, I need to know how many square feet I need to cover. So 143 times 169 is, hopefully I didn't punch in anything wrong, 24,167 square feet, or feet squared. And now I can just set up my ratio. I know that if I do bags over square feet, I know I have one bag will cover 350 square feet. How many bags will cover 24,167 square feet? So again, to figure out what I need to multiply the 350 by, and that will tell me what to multiply the 1 by, all I do is 24,167 divided by 350. Again, I have converted to using a calculator because I'm not about to do all this by hand. 24,167 divided by 350. So I get 69.04 blah, 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 blah. So it looks like 69.04. But so again, I'll multiply the top by 69.04 blah, 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 blah. So we get 69.04. So, but this is a real life problem. So you have to say to yourself, okay, now I can't buy 0.04 of a bag. Is it enough to only buy 69 bags? Well, no, because then there's a little section that you won't be able to cover. So therefore, you must buy 70 bags. So buy 70 bags. So this is not one where you would just round down to 69, because you really have to be able to cover every bit of that foundation in real life. So you have to buy enough to cover it. And even if it's a little bit over 69, you know you need 70 bags. We're moving on. After the first 15 minutes of laying down cement, you had used 1/5 of the bag. What is the rate you are laying the cement in bags per hour? Okay, so we know we need bags per hour. And in the end, they want a unit rate, so they want per 1 hour. The issue is this is 15 minutes. 15 minutes is what part of an hour? Well, there's 60 minutes in a whole hour. I'm just going to do a clock. There's 60 minutes in a whole hour. So right here, we're up to 15 minutes. So here's 15 minutes out of that hour. So what part of the whole hour is that? That's 1/4 of the hour. Or you could just do 15 over 60. Divide top and bottom by 15. And you'll get 1/4. So now I know in 1/4 of an hour I've used 1/5 of a bag. So I do 1/5 of a bag over 1/4 of an hour. And then I say, how much of a bag would I use in an entire hour? Well, 1/4 times 4 will get me to 1. So then I have to do 1/5 times 4. 1/5 times 4 is 4/5. So I'll use 4/5 of a bag in 1 hour. And then I want to write an equation that represents the relationship between the number of bags Y in X hours. So we know Y equals our constant of proportionality times X. That's our equation, how we'd write it. So Y would be equal to, what's our constant of proportionality? That just means what's your unit rate. 4/5 of a bag in 1 hour. 4/5 times X. X is your number of hours, so 4/5 times however many hours you've been working will give you the number of bags you've used. We're almost done. A couple more little problems. Your uncle is able to work faster than you. He uses 3 bags for every 2 bags you use. Is this a proportional relationship? Explain your reasoning using the coordinate grid. So first of all, let's let X represent your uncle. Number of bags, your uncle. And let's let Y be the number of bags you use. So if we have X and we have Y. So every time your uncle uses 3 bags, you use 2. So now if I double that up, if he uses 6 bags, I double that up, you've used 4. 3 times 3 would be 9. 2 times 3 would be 6. So after he uses 9 bags, you've used 6. And so we're trying to figure out, is this a proportional relationship? Let's just plot those points. Let's plot 3, 2, 6, 4, 9, 6. Ooh. Obviously, I put the line in before I put my points in. So there's 3, 2. There's 6, 4, there's 9, 6, and as you can see, once you draw a beautiful straight line through those, it does go back through the origin. So yes, it's proportional. It's a straight line through the origin. And then finally, what does 0, 0 represent in terms of the situation being graphed? It represents 0 bags your uncle uses and 0 bags you use. When your uncle hasn't done any work with the bags, neither of you. Hopefully that helps solidify some stuff about scale drawings and how it relates to the unit that we've been working with.